For C, the graph of x has one point of inflection. What is it? So point of inflection means we're going to derive this and set it equal to 0. When you derive this, we probably want to do quotient rule. Now, could we put the x squared under both of these and do them separate? But aren't we going to have a quotient rule anyways? So I'd rather just keep it like this and do my quotient rule. So when I do my quotient rule, what do? Well, we got to go back to thinking about it. We derive the first, which is, what's the derivative of 1? 0. And what's the derivative of ln x? 1 over x. Isn't that negative? And so that's the first one. And then we times that by what? X squared. That's my first piece, right? And then we minus. Well, don't we leave the top and derive the bottom? What's the derivative of the bottom? 2x. And this is all over what? X squared squared. And isn't this f double prime x what we're finding? Now, what are we going to do with this? We're going to set it equal to 0, right? When I do that, when I set the bottom equal to 0, does that exist? No. So can I ignore the bottom? Yes. Okay. So I had it at the top equal to 0, so let's rewrite this. What's this going to be right here? Isn't that going to be negative x? And this one, won't the negative distribute? Won't that be minus 2x? And this is 1 minus ln x. Does that look good? Is there a GCF? In order to solve this, can I pull x of GCF out and GCF of x out of both these? Or negative x? Won't that leave me... Oh, wait, that's dumb. No, it works. Won't that leave me with 1 plus 2 1 minus ln x? We okay with that? Can we now... this is negative x. And if you distribute this, it looks like we'll get 1 plus 2, isn't that 3? Minus 2 ln x. Are we okay? Now, what happens when you set this equal to 0? Remember that 0? And is 0 part of the interval? Part of the graph? No. So what I do is I set 3 minus 2 ln x equal to 0. When I do that, you're going to get x, you can get ln x equals 3 over 2. Is it negative or positive? It's going to be positive. So x is going to be e to the 3 over 2. So that is my point of inflection. Now, we minus the 3 over, divide by negative 2. That's my point of inflection. Now, how do we verify it is for sure? Does it say to verify it? No, but if we don't have to show we verify it, but how would you verify it? You plug in values on each side. So what I would probably do is I would probably find the second derivative. What's something smaller than this? Wouldn't it just be e? And then wouldn't you also try to find what's one bigger than this? Wouldn't that be e squared? Would you probably plug these two values in? And when you plug them in, well, if you plug in e to this nasty, I don't know if I want to do that right now. Crud. E, woohoo. Anyways, if we did it, it'll probably change. I don't know which one's positive, which one's negative, but let's assume it changes. But you could check it, which you probably would. Shoot, let's just do it. If I plug an e to the bottom, isn't that going to be positive? When I plug e here, what you get is you get negative e But let's actually plug it into this one right here. Negative e times 3 minus 2 times ln e. Now, isn't ln e 1? So isn't this going to be 1 times e? So isn't this negative e? So this is negative, correct? And if we plug this one in, we got e squared negative. And this is 3 minus 2 times ln e squared. Now, won't this 2 come in front and make that a 4? And then when that 4, it will become negative 1, so won't this become positive e squared, which is positive? So is this for sure a point of inflection? Yes. Woo! We checked it. That wasn't as hard as I thought. Oh, by the way, why didn't we check the bottom? Well, isn't the bottom going to be positive no matter what when you plug in the bottom?